This is the Jamboard practice assignment for the review on 2-4 and 2-6 solving compound inequalities and absolute value inequalities. So for number 1, we're solving this OR compound inequality, and we want to solve them separate. So first we have -8, so we want to add 8. We're multiplying b by -5, so next we want to divide both sides by -5. And it's that step there that requires us to flip the inequality symbol. And the second part of the inequality, right now we're subtracting 12. So our first step is to add 12 to both sides. And 11b is less than -88. So we want to divide both sides by 11. So we get b is less than -8. So the solution is b is greater than or equal to 12, or b is less than -8. So we want to fill out our number line. Feel free to increase by 4 so we can fit every value on our number line. We have b is greater than or equal to 12, or b is less than -8. So if you notice, one inequality is filled in because it can be equal to 12, and the purple side can't be equal to -8, so it is an open circle that's not filled in. Number 2 is also a compound inequality. This is an AND compound inequality. And remember, we have 3 parts. We have the middle, the right, and the left. The goal is to get x isolated in the middle. So our first step is to deal with the positive 11. We're first going to start by subtracting 11 on all 3 parts. Okay, now we're multiplying x by -5. So our last step is to divide all 3 parts by -5. Now we're going to need to flip both inequality symbols because we divided all 3 parts by the negative number. So the solution is x is greater than or equal to -11 and less than or equal to -5. Make sure your number line is increasing. I'm going to increase by 2, and I'm just going to go through odd numbers. It's going to be filled in at both -11 and -5, and it's an and, so we're shading in between. Number 3 is an absolute value inequality, and our first step to solve all absolute value inequalities is to isolate the absolute value. It kind of looks like 2 minus 4, but it's not. It's +2, and then you're multiplying -4 times the absolute value. So our first step to isolate is to subtract 2. And then divide by -4. So we divided both sides of the inequality by -4, so we have to flip the inequality symbol. And that's going to change. It looked like an or to start. It's going to be an and because it's going to flip to be less than. So the absolute value inequality that we are looking to solve is the absolute value of negative x plus 4 is less than or equal to positive 5. So it's less than, which makes it an and inequality. So we set up the right side. Follow the direction of the inequality symbol, which is just the same as flipping the inequality symbol, and make that left value negative. Now to solve this compound inequality, we're going to subtract 4 from the middle, the right, and the left. And we're not quite done. We still need to divide all three parts by negative 1 because of that negative x. So the solution to this absolute value inequality, make sure you flip there because we divided by a negative. So x needs to be greater than or equal to negative 1 and also less than or equal to positive 9. I'm going to increase by 2 with odd numbers again to make sure these all fit. And this is an and inequality, and it's filled in at negative 1 and at positive 9. And we shade in between because it's an and compound inequality. For number 4, the length of a rectangle is 20 meters longer than the width. The perimeter must be between 80 and 100 meters inclusively. That means it includes the values of 80 and 100. We want to write and solve a compound inequality to determine the possible values for the width of the rectangle. So first, let's define the length in terms of the width. The length is 20 meters longer than the width. So length equals W plus 20. Now I've given you the perimeter formula. We need twice the length plus twice the width. So we're going to substitute W for width and W plus 20 for L. So 2 times W plus 20 plus 2 times W. So now let's move on to the compound inequality part. The perimeter must be between 80 and 100 meters inclusively. So the perimeter has to be less than or equal to 100 and also greater than or equal to 80. Okay, whenever you see that word between, that's going to mean that it's going to be between, meaning an and compound inequality. So now we have our expression for P, this expression in green here, and we put P in the middle of our compound inequality. So now we want to substitute the P we have in the compound inequality with the expression that we've made for the perimeter. Now, because we're multiplying the expression of w plus 20 by 2 and w by 2, we can start by dividing all three parts by 2. That might save you a few steps instead of distributing by 2 and then combining like terms. Not by w, by 2. And to be honest, I'm taking a little bit of a shortcut here because this app is dragging a little bit, and I want to get to the solution. Okay, so that cancels out the 2 in front of w plus 2, and it also cancels out the 2 in front of the w that represents the two widths. So now let's simplify. So we've got 40 w plus w is 2w. We've still got that plus 20 in the middle of the compound inequality, less than or equal to 50. Now we want to solve for the possible widths, so we want to subtract 20 from all three parts. And you can't see that because of my face. Sorry about that. So now we just want to divide all three parts by 2 to determine the possible widths of this rectangle. So the widths can be anywhere between 10 meters and 15 meters inclusively. That's it for the quiz review Jamboard practice assignment on 2-5 and 2-6 solving compound inequalities and absolute value inequalities.